If 0 is less than a squared, what do we know about a squared? It's a positive number. Nice job. Does that mean that a is positive? Not necessarily. Very good. If a squared is less than b, what do we know about b? It's a positive number. It's definitely a positive number because a squared is positive and b is greater than that. Okay, that's going to be important information. Next, we want to know which of the following are always true. In math, sometimes things are never true. Sometimes they're true for certain conditions. They're conditionally true. And sometimes they're always true. That always is really important. Okay. A. Does A have to be less than B over A? Well, if you're having trouble understanding how you would even arrive at an answer there, think about going from the original statement. I'll write it larger. How do you think you can go from that to A is less than B over A? Algebraically, what can you do to this to make it look like that? Sam. Excellent. You can divide the whole thing by A. That takes this out and it puts an A over that. The 0 doesn't really matter. Well, does it follow that this has to be true? Like algebraically, we can see how we can go from here to here by dividing everything by A. But does this mean that this must be true? And why? What's the situation in which it might not be true? A
is less than B. Negative.
If A is negative, if A was negative and if we divided by it, Jake, what would we have to do?
What is it?
Yeah, so we have an inequality here.
Yeah.
If we're dividing an inequality by a number,
Yeah.
and if that number is negative,
Oh, you have to flip this on.
we have to flip the signs. So this is not necessarily true, because if A was negative, we would have to flip the signs. Okay? So we can eliminate this one. Again, allow yourself to think. The next one, does a to the fourth have to be less than a squared times b? Again, how can you go from the original statement to a to the fourth is less than a squared b? Algebraically, what can you do to this to get to here? Multiply by? Excellent. Multiply everything by a squared. I love that you're thinking. Okay? Ignore the 0 part of it. We can see how we can algebraically get to this by multiplying by a squared. Does this have to be true?
No. Yes.
Jake, why not?
Because like A could be 2 and B could be like 1,000,000. Oh no, wait. I take that back.
Okay?
A could be 4 and B could be like 2.
But take a look at your original thing here. If a is 4, 4 squared is what?
16.
Is 16 less than 2?
Oh, so B has to be. Oh yeah, then it would make sense.
Okay. Scott, why did you say yes?
I can't find an example. Wait, that wouldn't be true.
What do we know about a squared? It has to be positive because you're squaring a. And when you square a number, it's always positive. Okay? So this one looks legit. The last one, a squared over b is less than 1. What do you have to do to the original statement algebraically to get to a squared over b is less than 1? What algebraic maneuver? Divide by b. Very good. Okay, so what's b over b? 1. So that's how we're getting to a squared over b is less than 1. Does that have to be true?
Yeah.
What do we know about b in terms of its polarity?
Greater than a squared.
Which means that it must be?
Positive.
Yes! I love it. You guys make my day. It's true because algebraically it's legal, and also b is a positive number, and when you multiply or divide by a positive in an inequality, you do not flip the inequality sign.